Well, welcome. This is our February edition of the OSA Community event. I'm Inessa Pawson, Open Source Program Manager at OpenTeams and Head of Open Source Architect Community, the host of today's event. A few words about our community. OSA Community is a trusted circle of open source builders who are shaping the future of technology and digital intelligence. Our members are the human network behind many foundational and widely adopted open source projects. And Eric Charles, today's speaker, is one of the very active contributors to the Jupyter ecosystem, and also Apache. So super excited to have Eric to be presenter at today's event. A few more words about the community. The roles and responsibilities of our members within their organizations may vary. Software architects designing enterprise-grade solutions with open source, maintainers keeping critical infrastructure running, educators training the next generation of practitioners, founders and CTOs building open source-driven startups and enterprises, academics connecting research with real-world impact. But at the core, we are a community of open source builders. So if it sounds like you, I invite you to join us. And just a few pointers why it's worth your time to join this community. Connect with a trusted network of peers and experts who build with open source. Grow through our professional development program, including training, networking events, and certifications. Explore customer and partner acquisition opportunities, and recruit top technical talents through the POSI Alumni Network, our pipeline of trained open source developers early in their careers. If it piqued your interest and you would like to join, I must mention that membership to this community is by invitation, nomination, self-nomination. There is a link on the screen. Also, there is a QR code for you to apply directly. And if you know someone who builds, maintains, teaches, or leads in open source and you think should be part of our trusted circle, please feel free to extend the invitation. Just a few words about the OpenTeams, the sponsor of the OSA community. We believe software and people are at their best when open. OpenTeams is committed to helping organizations, big and small, break free from proprietary SaaS while sustaining the open source ecosystem that makes innovation possible. OpenTeams is advocating and building a decentralized, resilient, and innovative AI economy where everyone can thrive. If you're looking for ways to implement autonomous AI systems in your organization, let's connect. And I will put links and email address in the chat. And also, if you're looking for other ways to leverage open source technologies, let's talk too. And with that, on to the topic of today's event. And today we're talking about something very much a buzzword in 2026, MCP, the Model Context Protocol. It's changing how large language models plug into the world, providing a clean, standardized way for LLMs to discover and invoke external tools through a client-server architecture. So today, that usually means one tool call at a time, structured, predictable, and effective until workflows start to sprawl. So in this edition of our monthly webinar, we turn up the volume with MCP Code Mode. And this is a paradigm shift in tool interaction. Instead of dribbling out isolated tool calls, the model writes executable code and invokes sequences, coordinates MCP tools directly. And I will pass the microphone to Eric Charles from Datalayer.ai to show us a whole new way to build with AI.
Great. Thank you so much, Inessa and OpenTeams, for having me today. Indeed, to talk with you and share with you how you can leverage MCP Code Mode to do better, I'm going to say, agentic workflows, to do them cheaper and faster. So a few words about myself. I know Inessa already shared that. I'm a strong open source contributor for different projects, Jupyter, Apache, and I am also the founder of a startup called Datalayer, which builds and allows you to manage agents which are very focused on and performance for data analytics. We do have a SaaS where you can try those agents, and we also have extensions for Visual Studio Code and Jupyter. So I don't know about yourself. So first of all, welcome, and very happy to have you on this call. I'm going to consider still you are interested in AI. You know what a bit, at least a bit, what MCP is, what an agent is, what an LLM is. So at some point, if you are lost, maybe you can put in a chat, hey, we lost. I don't know, Inessa, if you want to take question, but if you see a storm of questions, just stop me, please. So I'm going to start with a case, with a small demo directly, just to set up the scene. And then I'm going to, which is a typical agentic agent case with MCP tools. And then the question is, can we do better? And the answer hopefully is yes, thanks to programmatic tools. I'm going to detail a bit more what it is. And then I'm going to do the same demo, but at that time with code mode enabled, and we're going to see the difference. So what is a demo? Let's say we are on the right. We are like the AI engineer, and our manager or our business stakeholder on the left ask us something. Typically, he knows that AI is the way to go. At least he believes in that. And what he needs to do is grab CSV files from a Google Drive. And there are many CSV files, and he wants to do some manipulation. In this case, maybe just concatenate, but maybe it's filter, aggregate, or whatever. And he wants to push the result of that manipulation into a GitHub repository. So go from Google Drive, take the CSV, and push that to GitHub. And of course, do that with an AI agent, because AI agents is the way to go. I don't want any more ETL, extract, transform, load. This is old-fashioned. I want the new way. And so you think like, hey, yeah, but the agent needs to pull all those files, all those details into the LLM context. And so you are a bit skeptical, but you're going to try still. You're going to try because you are positive and you want to try out. And now I'm going to give you a bit more details about the case. So we have those CSV files into the Google Drive. There is not 1,000 CSV files, but yeah, for the sake of the demo and talk and burn, there is just a few of them. And this is then the GitHub repository where you can see a single CSV file, which is the aggregation of all those CSV from Google Drive. And then just a little word about the stack. So what you're going to see is this new name for you is Code AI. It's just a CLI which connects to what we call an agent runtime. So I show you all this repo and new names just to show you that the demo I'm going to give you, you can run it from your laptop because it's all open source. It's in the Datalayer organization. And an agent runtime is a Pydantic AI agent, which is accessible through AJUI or Versal AI or A2A protocol. And then the agent we're going to use, we define that agent with a spec, a specification. And for us, a specification is, of course, an agent, in this case, Pydantic AI with some MCP server. And because we're going to connect to the Google Drive, which is my Google Drive, my GitHub private repo, we need some environment variables like some secrets. Right. So let's go here. And I'm going to start easy with a video. And so this is a Code AI, the CLI, and we ask aggregate all CSV files located in the test folder of my Google Drive into a single file, name blah, blah, CSV, and save that to the GitHub repository. So here you see in MCP tool invocation. And this is a lock of the MCP server. And now it's going to take a bit more seconds. And I'm going to just jump to the end of this video. just to show you the result, which is, okay, so task completed. Those 5 CSV files downloaded, each in the context, and then upload it again to GitHub. And you're gonna see here this number, which is 291,000 tokens used. So let's keep that in mind. So this is a case without Code Mode. Okay. Now we move back to the slides, and the question is, can we do better? Yes, we can with Code Mode. And Code Mode is like, maybe you're going to find other names, programmatic tool, maybe yet other names, but the initial, publication, well-known publication, I'm going to say, is from 6 months ago from Cloudflare. They do have a well-known agent, and they said, well, they did some experiment and they shared that paradigm and they name it Code Mode. And then Anthropic also shared this blog post on November last year, so 4 months ago, just to confirm in this blog post that Code Mode was something to be considered for data case. So now I'm going to show you a bit more details about the LLM context, which is managed and built and maintained by the agent. On this picture, the context is here in the middle. You have the LLM on the left, and you have the, for example, MCP server number 1 with 5 tools and MCP server number 2 with 2 tools. So a typical process for the agent is to maintain in its context window, first of all, the system prompts. Well, that's a given. But based on the MCP server you configure, the very first step is to ask the MCP server, what are your tools? Give me the specs, the definition of your tools, so that I know, or I can tell the LLM, hey, LLM, you have those tools available for you to be used. This needs to be done for all the tools. So 5 plus 2 is 7 tools definition, which gonna be passed every time to the LLM. The user is gonna prompt message 1, the full context given to LLM. LLM may decide to use a tool number 1. So it's going to reply, hey, you have a tool number 1 for MCP tool, MCP number 2. Please invoke that with those parameters. And then we get reply and we continue. And at some point we get the response that the LLM or the agent is going to show to the user, right? So this is standard, typical way. As you see, we have quite some place taken by the tool definition. And now we're going to see how this goes with Code Mode. Code Mode, we have here the MCP server still, but you see new boxes. You see first a Code Mode toolset. Toolset is a Pydantic AI nomenclature. It's how you add tools to the agent. In this case, we defined or we implemented a Code Mode toolset. And the new box you see also is a sandbox here. It's a code sandbox, is to run the code that will be generated by the agent, by the LLMs through the agent. What you see is quite some difference in terms of the tool definition here. You don't have, when you start the agent, all the tools definition of the MCP here on the right. So what you see is by default, you can leave the MCP server, you can search tools, you can get the tools details, and you can execute code. That's all you have when you start. Whereas on the left, you had a lot more because you had on prior execution to get all the definition of the tools. And then based on those primitives, actually, the LLM can search tools. I mean, you want something about GitHub, so it's going to use search tools with GitHub and maybe pull requests or whatever. The Code Mode toolset is going to reply. It's going to add the tool details. And now he has the definition he needs. So it's much more incremental. And we will see a bit like some example after. But this is all the concept. Here on this picture, you get the tool definition very, very small. with some primitive, and then the LLM can use those primitives to grow its tool definitions instead of having them fully loaded when it starts. At some point, of course, the tool definition will be loaded and can be used. So coming back to the initialization step, because we're using Pydantic AI, we are in the Python world. If you're using, I don't know, Cloudflare agents, toolkit, maybe you're going to have JavaScript, but the principle is the same. Principle is that agent starts, and let's say starts and knows that there is a Tavily MCP server. Tavily is something that allows you to search on the internet to get a web page details. So you have crawl, extract, and search tools. And the very first step is to convert those tools into, in this case, one Python file per tool. And this Python file, what it does is very easy, very simple. Well, you have the description. This is very key, very important. Description in a Python doc. But what it does call tool, and behind the scene, call tool calls the MCP server itself. But what you expose is not the MCP. What you expose is a method. It's Tavily extract, which is an async method. And LLM can see now that you want to invoke a method, a tool, so you don't invoke MCP. You have to write down some code to invoke the tool. And this is an example of code which is generated from generated MCP Tavily, import Tavily search, and result is await Tavily search, and so on. Result is less tokens, meaning less cost and less latency. So we have two ways to get less tokens. One, again, the definitions, and the second one is the intermediate tool result, which can be piped, and LLM can generate code actually to pipe and give return the result of the first tool call to the second tool, to a third tool, and so on. So it can pipe the tool method. Let's take an example. In this case, we want to search on GitHub, get the open issues, which is a labeled bug from Pydantic AI repo, for example. And then we want to send those list of issues via email. And we want to summarize those issues or just extract metadata and put them in the email. Again, we're going to use those two MCP server, GitHub and Google. And let's say we here typically the first way to show the difference is the tool definition. I share that. Here you can explode your context window because you have so many tools. And this is a very simple example with two MCP server. If you go with 4 or 5 MCP server, all those tool definition are going to blow up a portion of your context. Whereas with the MCP programmatic tool, you don't, I mean, the more MCP server you add, the same usage you have in your context. So you don't grow based on the number of MCP server. And then in this very specific case, let's say you want those issues. So the first actions is to call the MCP server, give me the issues, put them in the context, and then send those issues to the send Gmail tool. And the send Gmail tool is going to be nice. It's going to send the mail, but it's going to reply as a result of the tool invocation with the effective email he has sent, so that the LLM knows, okay, this is effectively what you have sent. So the result is that you're going to load twice your LLM context, once with the effective issues you get back, and the second one with the email. Whereas here, so this is an example of generated code. The LLM is going to say, okay, I'm going to import list issues. I'm going to get the result here in memory. This is running in the code sandbox. It doesn't go to the LLM or to the context. Issue result, I take the issues and I invoke the code to send the Gmail message. And if you prompt, for example, okay, don't return the email, but just return the number of issues, which has been fetched. After you send the mail, just return me the number of issues. LLM is going to add some code here, and it's going to say return email, len of issues. So ultimately, if you are not interested on the content with the content of the email, you're going to have a big gain because those intermediate results are not stay in the sandbox, don't flow back to the context. And for this specific example, we did some experiments and we got 85% gain in tokens, meaning 85% gain in money, effectively, because you pay your provider per token. And you get also faster because you have less force and back between the MCP and the agent and the LLM. So you go faster, and anyway, speed, time is money. So you get even also a gain in terms of money, and you go twice faster. And these are numbers which are validated by the community or by different experiments around the place. And I have put here a few links. You can get an 80–90% gain. Cool. So now we're gonna go back to the initial demo with those CSV. And what we're gonna do, we're gonna add two more library repositories. This is just listed for info. This is the same setup, but because we're going to launch the agent in code mode, we need the agent code mode. And remember, we need the sandbox. So we're going to use the code sandbox. And this time I'm going to do it live. So I'm going to launch here in my terminal, the Code AI, which is the client, which connects to the runtime. And the runtime launch and is ready to be used. In this case, it runs on my laptop, can run anywhere, can run on the cloud. We connect with AJUI. We use Bedrock, Anthropic, in this case, the latest one, Opus 4.6. We have Code Mode enabled. We use a local eval sandbox, and we have those two MCP server. And those MCP server has generated, just to show you, here, the MCP, and this is what it has generated. So GitHub create branch, and as I showed you on the slide, you have some Python code to be used. So I'm going to launch the experiment to aggregate the CSV files. The same prompt, exactly the same prompt. And now what you see is that it's going to use here generated MCP Google Workspace import list. And then it's going to combine that to finally see that it has the same structure and again execute some code. And now, if you remember, we had like 290, so 300K. Normally, it should be here in this example to 100. So we divide by 3 because we don't have a lot of CSV. If we have way more CSV, the gain is going to be indeed to those 90%. So here, yes, roughly 100. We had, if you remember well, 300. So we get way more efficient token usage. Right. So this was my what I wanted to share. And to summarize, with Code Mode, you get no program can do better than without Code Mode. 2 key commands. Still, you need to have well-defined tools on MCP because the more well-specified your tools are, the better the code which is generated will be in terms of typing, Python typing, and so the better the LLM will know which parameter to give. And then I didn't talk or mention a new, quite trendy word, which is skills. Well, you have the MCP, but you also have the skills. And with the open source library I shared, this is exactly, skills are exactly the same as tools. They can be converted to programmatic tools, and they can be piped together. So whatever you decide to ship as access to the outside world, whereas it is MCP or skills, Code Mode applies to that also, to skills also. And I find that quite nice that there is a way to mix those two ways to enrich the agent and still benefit from the Code Mode goodness. So thank you. With that, I look forward to any question now or just after on the GitHub repo or whatever. So thank you so much.
Thank you, Eric. And I will open up the floor for the questions. Feel free to use audio. We have a small group, so that's okay to use audio or post it in the chat, whatever you prefer. But while the audience is thinking of a question, I have a question for you, Eric. Can you think of scenarios where the code execution approach would not be suitable or would introduce complexity without benefits?
Yeah, Code Mode is especially suited for MCP tools, which connects to API and which needs to return some data, right? If the question is just yes or no, the gain will not be there. I mean, if the answer to the question is yes or no, you won't get any gain. However, I don't see any drawback to always run in Code Mode, because even if you don't have gains, you won't lose anything, right? Because under the hood, it's exactly the same. There is like this interaction with MCP, so it's always MCP behind the scene. But there is the intermediate code sandbox where you do some those pipings of method. So I don't see any way to lose feature or to lose something. Maybe no gain again, but that's fine.
That's great to know. And I'm guessing it also allows this scalability because as it happens, like good ideas come kind of in sometimes over time. So you might build something and then you want to add to it. And if you start with a code mode, then you're already prepared to extend your application.
Yeah.
I will give another chance to our audience to ask questions. Chris,
Thanks for the demo. I'm trying to just better understand the distinction between code mode and then your agent or your CLI. So in this case, code mode is different from the code AI. Code AI was just a CLI that helps you interact with your agent. And then code mode is something that will, as you described, translate the tool definitions into code. Who takes responsibility for that code? Is that something that a MCP server provides, or is that something that I have to instruct code mode? Let's say if the generated code has an error, how does that work? So I'm trying to just get a mental model of like, where does this code live?
Yeah, good question. And sorry for the confusion in terms of the wording. Indeed, Code AI, it's just a name for the CLI. You can forget that. But yeah, excellent question, because I did not explicitly explain that. But here, and again, the code mode paradigm can be applied to, well, every agent has to apply the code mode paradigm on his own way. So if you're using LangChain, you're going to have to, and especially LangChain Python SDK, has to implement the tool set or the tool for code mode in its own way. LangChain JavaScript in its own way, and so on and so on. So for this demo, what I shared here is the code mode tool set, which is created specifically for Pydantic AI. Okay. So this is a responsibility of this box to go to the MCP server, ask the tool's definition, and create those generated files. In our case, this lives in this repository agent code mode, which is for now just Pydantic AI, and we generate the programmatic tools from the MCP server and from the skills and expose them as that code mode tool set. So
Okay, so
is
yeah,
it
yeah,
more clear?
yeah, that clarifies. I'm just trying to understand if I'm somebody who's typing, please aggregate this data. And I was trying to imagine a scenario where I would not be happy with the generated code, if that makes sense. Like, let's say I wanted to do something else. Would I just go somewhere and edit it directly? But it sounds like I would go to a skills folder, update description, and then the code mode would take care of generating the appropriate code.
Well, if you're not happy, well, I can understand the question and the concern about you as a user not being happy with the code generated. But yeah, so there is first the code generated to access the tool. So there is not a lot to change because it's just a proxy, right? The code, which is every file here is just a proxy to the effective MCP tool. Okay. But indeed, after what the LLM is doing is it is generating, and sorry if I jump here too much, but this code is indeed based on your prompt is generated by the LLM. And at some point, the LLM is gonna realize that the code he has generated maybe is not correct because the owner or the repo is needed and he has not given the repo, so the code is gonna fail. But the LLM is going to recover. You as a user, you can prompt or give hints to the LLM so that it's going to use the correct assembly of method. But again, if as a user, you should not care about that. The system prompt should care about it. And also the tool definition of the MCP should be typed enough so that the code knows that, I mean, the proxy tools know that you need to give an owner, a repo, and a state as parameter.
Okay, yeah, that makes sense. Thanks.
We have time for more questions. You feel free to put them in the chat or use audio to ask directly. I have another question for you, Eric. I happen to care about security, and in my free time, I try to educate myself on cybersecurity. So the question I have for you: what kinds of privacy or security benefits might code execution code mode offer over traditional MCP tool calls?
I would say the first thing that needs to be clearly set up is a code sandbox, and as its name tells, a sandbox is something which is completely independent of the rest. So in terms of security, there is like maybe this additional building blocks that needs to be correctly set up, and indeed, I would not say this is an additional point of attack, but this is obviously, and to come back to your question about code mode, your first question, is there any drawback? Maybe this is one drawback, where there is like this additional component you need to have, but you have many provider shipping now sandbox, which are well suited for LLM. But so in terms of security, this is something you need to take care. I mean, if the sandbox is shared, you have the secrets over there, but because you need those secrets to connect to your GitHub repo. But I would say anyway, if you use MCP server, you also need those secrets. So I would not consider that as an additional requirement to protect the secrets. But yeah, the secrets needs to be injected in the sandbox, so there is more machinery. But maybe there is also a place to audit all the actions and to build like a very strong place, so as a single place. So this is also an opportunity to bring more security. Other than that, yes, you still have to deal like typical flow with AI agents just to secure your to protect you against prompt injection or prompt I mean context discovery. It doesn't change that at all.
Thank you. Well, I don't have any questions, but I hope the audience have more questions. Well, everyone is a bit quiet today. I understand this is we're coming to the end of the week, so maybe we are all running out of steam. If you think of questions for Eric later, Eric is a member of the LinkedIn group, so feel free to pin him there. And I want to thank Eric for this presentation. It was very informative. I personally don't work very closely with MCP servers. It was really cool to learn about this new paradigm. I also want to say that I am truly excited to see all the new projects from the data layer team becoming available to the dev community. I know there's a lot of development that has happened in the past 6 months. Feel free to share your work, the work of your team in the LinkedIn, so the people here on the call and in the community are aware of it. And I want to thank our attendees. Thank you for spending this morning, afternoon with us. I know you have a lot of options. I'll be posting the presentation on the OpenTeams YouTube channel in the coming days. So if you missed anything or just want to revisit some of the highlights of today's presentation, it's coming. I really appreciate all you being here.